Hey, um, let's do some more questions. I think I would like to do more questions today in one go. Let's see how it goes. But I'd like to do okay. And I have done this already as well in valid palindrome. I guess this was quite easy. So let's start with inverted binary tree, and we had this open already. Here it is. Pretty standard question, right? Everyone jokes about it on YouTube and Instagram regarding the technical interviews like, hey, can you invert a binary tree? Can you? So, yeah, pretty much what it is all the left children should be right children, or right children should be left children. It's just like you are looking into a mirror. So, you can see if you place a mirror here, I mean, just right here, um, it should be mirror image of this, right? So, I guess it should be easy for me to do it. Mm-hmm. So what we need to do is, suppose we are at level 1, we get to level 2, and we are at we are at level 2, and so how many traversals I can do in order, post order and pre-order. So I do not remember how they goes. I actually forgot like those traversals. But let me check with the audios recording. Yes, audio levels are up. So yep, yeah, fine. So let me just try it out in my mind. If I go to the left, then I have to go to the right as well. Swap these two nodes. When I swap these two nodes, automatically 7 is there and 2 is here, but the children nodes are not yet swept. So when I go at 1 and there's a 3, we need to swap. It means given a node, right, x, we need to swap left of x to right of x. And I believe, suppose we are at 1, right, and we are at 3. No, we have already swapped 4, 2 to 7. Okay, so we are at this point now, 4, 7, 2. Now we go to subtree 7, 9, 6. Here we will try to swap 7, its children node. So it will be at this like 9 and 6, and similarly for this one. So I believe I can do okay. All again, I do not remember the order traversals, so I'm really sorry about that. I'll revise it just after this, or just now. See, pre-order, post-order, in-order, tree traversal techniques. So, tree structure can be traversed in following ways: DFS, in-order, pre-order, and post-order traversals. And there's a BFS, that is level order traversal. So let's start with in order. Initial traversal from root node to leftmost node. So this is in order. Means if our binary tree is sorted, you will be getting a sorted order, in order, right? In order, as name says. So I don't think so this is a balanced binary tree, right? So I mean, it is balanced, but it is a binary search tree, right? So yeah, so in order has no effect on it. So initial traversal from root to leftmost node, then its root, then its rightmost node, then its root. Okay, I mean, cover all the left, then root, then all the right, then root, then all the left, no left, then all the right, then root. I believe if there were any subtree to this 5, it would have been traversed first before going back to 1, right? Yeah. Because see, yeah, leave it. I guess that is enough. So that is in order. So I don't think so I'm going to be doing in order. So if root equals null, then return. If then in order, like go till left, right, and visit the current node data. It will go till left, recalls, and it will give the leftmost node data. And after popping, it will give root of that leftmost node. Then it, after giving the root, I guess whatever in the stack is there, it will pop out, right? Um, Suppose 1 is in stack, 2 is in stack, 4 is in stack. Now there's nothing, so it will print out 4, right? Then it will call again, there's nothing. It will go back to 2, right? And it will print out 2 as I think, yeah, it will print out 2 before going to the right. Then if you go to the right, that will push back to the stacks, and 4 to 5. Then 5 will be popped back, right? 5 will be popped back, and at the top of stack, see 4, 2 and 5 is gone, so at the top of stack there's 1. So we will be popping that out, obviously. Then we go right and right. Yeah, I guess I got the point. Then there's pre-order traversal, means I believe visit the root first, then left tree, then right tree. All the left sub left. I believe left tree. So printout statement will be at first, right? Yeah, printout statement is at first, then left tree, then right tree. So post order will be like printout statement last. Yep. So this is what it is. There's one level order traversal. We go 5, then we go to 12, and then 15, then we go to 7, 14, 2. I guess we need to do a level order traversal to make it, like, to solve it, right? Because first we will go to 5, right? Then we will swap everything. Then I'll go to left to 13. I'll swap everything. So, and then I'll go to 12, and then I'll swap it. And then we'll go here. 2 will be at first, then we will swap it. Then 14 will be at second, we will swap it, and 7 will be at last, we will swap it. At last we will go in the bottom. If left or right is not there, we will leave it. If left or right is not there, we will leave it. So yeah, leave. I guess, yeah, level traversal will do the best in my opinion. I guess other traversals we can also use, maybe. Effectively that will be level traversal. I'm not an expert, and I will be expert in some time. You know what I mean. That is why I'm practicing. So let's see, audio levels are still there. Yep, audio levels are still there. And yeah, I'll start. To do the level order traversal, I believe we need a queue, as it is a BFS. So I will make a queue, QUEUE, of tree nodes. So queue of tree node, queue is there. And what is the constraint number of nodes in the tree in range of 0 to 100? Okay. So I'll be doing like if node, I mean root, equals return what? Null, right? And we'll start tree q node q dot push intermediary tree node to hold the value, right? To tree node x equals, I mean this needs to be star x equals root. I will use that. Now while, not while actually, while only, while q, right? Q dot pty empty, well q is not empty, I'll do this one if q, no, tree node x, I mean cur, right? Cur equals root and tree node star equals cur equals root and cur, and yeah, we'll do it this one if cur cur left, so, and right, and cur right. So what we will do is x equals cur left and cur left equals cur right and cur right equals x, right? So this one is swapped in my opinion and what we will do is we'll keep pushing the next nodes, right? So how will I pursue to add more nodes? Okay, I can put both of the nodes in, right? I believe so. So q dot push cur left and q dot push cur right, and we can do is next one, if there's only left subtree, what to do? Wait, command C, command V, if there's only left subtree, what to do? Let me zoom in. Yeah, so this one and cur right equals I mean I can do this as not, right? I hope, and will not be doing this then, and cur right is if it is null, wait, null pointer, so cur right is null, right? And cur left we have, so no need of temporary variable, and cur right equals cur left. I believe we should be doing command X, put it here, and remove this one, and we will just be putting cur right in the queue, and need to do else if next again else if there's only cur left is only there, that means we need to do left, I mean only cur right is there, then we need to do cur left equals cur right. Yeah, also yeah, I need to make it as null also, right? So left and cur right equals null pointer, and here cur left equals null pointer, and maybe we can return root now. Return root. I hope this works at least at some level. Alright. Not a matching member. Okay, I need to put a star maybe. This is going to take time. Memory limit exceeded. See, this is going to take time. Okay, I'm not popping out after taking out root, so I need to q dot pop as well. Yep, let's see. Again, memory limit exceeded. This is not TLE, right? This is MLE. Okay. Never experienced this one before. Why it could be? Let's analyze. So let's see the this level order traversal, how it is written. So we are taking a q, we are pushing it, yq is not empty. Okay, q dot front, then q dot pop. Alright, q dot push, and q left exist and q right exist. I have put these checks. So q dot pop, not root but q dot front. No, this will not solve it, but let's see. Maybe it will solve it. Maybe it will not. Okay, it solved it. Case has got resolved. Oh my god, I can't believe it. See, while let me submit this first. I'll add one edge case from my side. Okay, edge case is also there, already there. If the tree is empty, right? So yeah, this worked. Now let me submit it. Oh shit, I'm sorry. Alrighty, it worked. My god. Fine, is there any better solution? I'll look for it, this time at least. Let me check my submission. This was my first submission. Solutions. Algorithm solving step. Okay. So if root is empty, return null pointer, swap left and right children. So what he did, a tree node temp left is kept in this one, and this was swapped in front, and this is pre-order, right? This is pre-order. See, there's no pre, post or any order. Okay, it's all like when you do the operation on your what you say, tree basically. So the order you print and the order whatever you're going to do, eventually the calls are going to be like this one, right? So from left to right. Yeah, I'm taking my words back. Like there's no pre or post order. There definitely are. So yeah. Uh, Let me understand this one. Yeah, iterative approach. Mine is still quite big, right? Uh, I'm doing anything wrong or what? Q dot front pop. Then I'm checking if this one and this one, like both of them that are there. But it is showing tree node temp. It is just okay. While pushing, it is only taking care if it is null or not. Otherwise, otherwise it is just swapping. No care for if it is a. I mean, if it is a null or not. Yeah, you manually are putting it here. I thought it might it can give some error. I believe my code is also fine. No need to change it. Got the point. No need to worry about uh, nulls while swapping, but need to worry about when you're pushing. So yeah, this solution I got it. Other solution I need to understand. Example walkthrough. The fuck, he's doing so much for a solution post. And you want to understand this one, this solution right here. So how it is doing is first we are taking the root, and from the root we are just swiping left or right using a temp, right, and we are just iterating through. Looks right. This pre-order seems fine for this one because we are visiting root first, right? So this feels okayish. Yeah, correct. Where's the pre-order? Where's the pre-order? Here it is. So pre-order, we are visiting the roots first. So 1, then 2, then 4, then 5, then 3, then 6. I mean left first, then right first. Like complete the left subtree first, then right subtree first. Can we do the same thing in any other traversal? Let's analyze. So I believe in any any traversal we can achieve this one. Suppose we are at 4, try to swap it, cannot. At 5, try to swap it, cannot. At 2, yes, can swap it, 4 and 5. Now back to 6, cannot swap it. 3, yes, can swap it. Because yeah, in any traversal I can do it. In place of printing, I just need to swap it. Alright, fine, got it. Okay, this was quite simple. I never tried it, never put my hand on this problem. I was just nervous about this problem. So now actually we have done it. Been 24 minutes. I can do one more question in this video. Let's go to another question. This is valid anagrams. So this is going to be easy, right? What is anagram? Given two string s and t, return true if t is an anagram of s, and false otherwise. That's it. Means what is the constraint? Consists of lower case English letter. Anagram, true. Okay, got it. Given two strings, S and T return true if T is an anagram of S. What we can do is sort both of them. Uh, anagram. An anagram is a word or a phrase formed by rearranging the letters of a different word or phrase using all the original letters exactly once. All right. So what we can do is we can take one vector of characters, vector of char. This one, I guess, this kind of question I've done earlier, but not this one specifically. If I've done it, I don't remember it. So vector char alpha, we can do 26 comma 0, and that's it. ALPH alpha. Now what we will do is this one. 4 char x from S and alpha of A. A minus, I guess you need to subtract A from whatever letter you're getting and just increment it, and do same for, I'm sorry, this. I'm getting a call, but I'll pick it up, or I'll reply him after this this question. So this time T, I'll also end the video and start a new one. Kind of important call, but will not pause this video. Anyhow, XSXT, we are doing this. Now we'll check for this. I'll do a return true, and I'll check for int x. No. Don't make a char then. Make an int, and int x lp lph. If x not, right, return false. I mean, 0 is basically, I mean, something is negative. What about that? That should not happen, right? So I'll check if x is not equals 0. Better do this. Return false. I'll run it. Wrong answer. Anagram. Okay, you need to reduce it. What I'm doing right now. What the fuck? Right, we'll try to submit this one and we'll see. Alright, it's done. So yeah, we have done 2 questions, and I'll start a video right away after taking that call. Yep, thank you.